Good afternoon and welcome to this web presentation of a state-of-the-art automated tire and wheel production system designed, fabricated, and installed for CFX Logistics Incorporated. CFX now uses this system to build large volumes of tire and wheel assemblies and deliver them in sequence to BMW's assembly hall in Greer, South Carolina. CFX Logistics dedicates itself to providing integrated supply chain solutions for manufacturers in North America and abroad. They focus on close collaboration with their clients in order to find creative, proven, and cost-effective solutions to complex logistics opportunities. The company adds value through economies of scale, localization, modular assembly, and the use of automation. CFX is also able to leverage the experience it has gained from offering transportation services for the last 15 years. CFX was tasked with operating a facility to provide tires and wheels just in sequence to BMW to support the car maker's production of its X3 sport activity vehicle. And in order to make the economics work, CFX needed to leverage some of the equipment it had employed at its former facility in Newark, Delaware. The challenges for CFX were similar to those it had faced before in previous engagements supplying the automobile industry. They needed to receive and manage a wide range of wheel and tire stock-keeping units. They needed to be able to pick many different SKUs quickly to support a production line that needed to generate a completed assembly once every 20 seconds. The system they employed to accomplish the aforementioned tasks needed to minimize floor space, to minimize lease expense, and the amount of purchased parts inventory managed to reduce operating costs. Cycle times had to be quick to reduce space and minimize labor hours, and yields needed to be high to reduce rework and scrap. Finally, production data needed to be archived in a cost-effective and efficient manner. The automated system designed to achieve CFX objectives while operating within established constraints is installed at a facility leased from Prologis and located in Greer, South Carolina, in close proximity to BMW's assembly hall. The automated system is a collection of integrated subsystems that include a tire receiving, recognition, stacking, and storage process, wheel and tire retrieval, destacking, and recognition processes, element tracking, tire pressure monitor insertion, tire mount and inflate processes with concurrent data capture, balancing process, an assembly recognition, reordering, and quality control process, an assembly storage process, and finally, assembly retrieval, loading, and shipping processes. Astra uses blind receiving, which allows products to be received in the Exacta warehouse management system without an expected receipt order coming from the supplier. Tires are received on a trailer and are inducted into the yard storage zone. If a trailer consists of multiple distinct product IDs and/or FIFO dates, the operator will enter receiving data for each one of these distinct combinations. All putaways for a trailer will be stored in the same yard lane, and Exacta splits that lane into multiple Exacta locations as necessary. Wheels are received on pallets, and wheel product IDs use lot tracking, while weights and tire pressure monitors are received in case quantities. A putaway label is printed in the receiving area for everything received and placed with the product. Operators use RF mobile putaway to stock tires into the yard, induct wheels into their reserved storage zones, and induct tire pressure monitors and weights into their primary storage zones in the warehouse. Tires are inducted into the yard, but they must be replenished into the automated storage and retrieval system's raw materials buffer in order to be available for building of finished goods assemblies. Astra uses a gantry-style ASRS that includes 403 unique tire locations, and each location is capable of accommodating as many as 8 tires. Each day, the planning department develops a trailer move plan that details the order in which trailers are to be retrieved from the yard and the quantity of tires to be pulled from each respective trailer. To get the raw material into the ASRS, an operator uses the tire unload module to bring tires out of a trailer which has been stored in the yard. The trailer is brought to a dock door and opened, and associate removes the appropriate quantity from the trailer and places them onto a takeaway conveyor. The warehouse control system communicates with the conveyor control system to transfer the tires one at a time to a vision system. The vision system captures a digital image of the tire and compares it to a set of images in its memory. The vision system communicates the result to the warehouse control system. If the value is good, the tire is released to the stacker. Conveyor controls handle the operation of the tire stacker. A set of 4 tires will leave the tire stacker and be transported on accumulating conveyor to the ASRS pickup station. Once the set arrives at that station, the conveyor controls passes information for all 4 tires to the warehouse control system. The ASRS module of the warehouse control system directs the ASRS controls to place the raw material tire stack into an appropriate storage location on the raw material side of the ASRS. The ASRS controls communicate the result back to the warehouse control system module, and the database is updated. If the trailer still holds tires, it is returned to its lane position within the yard. Requests to build assemblies come from BMW via EDI messaging. Requests to ship assemblies come via broadcasted messages from queues. Exacta takes in both types of messages and copies the key data into staging tables. Then Exacta's import viewer picks up the stage data and turns it into real orders that can be processed within the plant. BMW sends Astra an order to build assemblies for a specific car a few days before it will be called for shipment. As soon as the order to build an assembly is imported from BMW, it is evaluated and logic rules are applied to create pick work orders to pull each component for the required assemblies, and then route the products through the automation system to put them together and stock the group of 4 finished tires in the ASRS. Tires are always picked from the raw material buffer of the ASRS. Wheels are always picked from the primary storage zone for wheels, also known as the pick-to-light zone. Both tires and wheels are picked in FIFO date sequence. All tires for a single order are picked before moving on to the next order in the queue. The ASRS module of the warehouse control system looks at the current open build to stock orders to find the one with the highest priority and due date. The ASRS module identifies the tire items for the current order and commands the gantry to move to the appropriate location to pick from available stock. For each distinct item to be picked from the ASRS, the warehouse control system will have brought forward 1 or more tires to the pickup station. If there are 2 or more tires that have been picked together, they need to be destacked. The tire destacker can handle up to 4 tires at a time and inducts these onto the line conveyor. After destacking and before flipping, there is a camera vision system on the line to check that the tires being picked are correct for the current order. The tire is examined by the vision system, which captures a digital image of the product and compares it with the images in memory. It determines the tire type being seen and passes that to the warehouse control system along with the orientation of the tire. The WCS compares that product ID with the expected tire for the current order. As each tire for an order passes the vision check, the ASRS module of the WCS adds the related wheel item to the pick-to-light work queue to trigger the pick-to-light in the wheel storage zone to bring the related wheel out to meet the tire on the line. When a tire is for a directional assembly, it may need to be flipped The rules for evaluation on flipping a tire include the tire's type, directional or not, the tire's orientation, and the tire's position on the car, left or right. Wheels are picked from their primary storage zone, which is a pick-to-light zone. Pallets of wheels are brought into this zone from floor storage during replenishment. Each product ID is stored in a separate lane in the zone. Each lane has its own pick-to-light device. The pick-to-light directs the operator to pick one wheel at a time in sequence to correspond with tires coming out of the ASRS. Each picked wheel is examined by a vision system camera, and a unique tracking ID for the wheel is used to track it all the way through the line, and is associated with the pick item in the Exacta warehouse management system. The warehouse control system communicates the expected wheel product ID to the vision system. The wheel is examined by the vision system, and it determines the wheel type being seen and passes that to the warehouse control system. The warehouse control system compares the product ID with the expected wheel for the current order. If the wheel product ID from the vision system is not the expected product, the warehouse control system stops the conveyor and sounds an alarm for an operator to resolve the issue. The wheel is transported on accumulating conveyor to a tire pressure monitor station. This is a poke-yoke system that is designed to help an operator avoid mistakes. A wheel will travel on conveyor and come to a stop in the zone associated with the insertion station. Controls passes the wheel's tracking number to the warehouse control system. The WCS determines the unique assembly to which the wheel is assigned and lights up the pick-to-light at locations for the products to pick for that rim. The torque value is captured and sent to the warehouse control system to associate it with the assembly's order. After the tire pressure monitor or valve application, the tire and wheel enter the soap, mount, and inflate area. The components are cleaned, mounted together, and the assembled tire is inflated. From this point forward, the tracking IDs for the wheel and tire are joined together to create a new tracking ID for the assembled tire. The warehouse control system passes the assembly ID to the balance machine. There, a person is instructed what weights to place on the assembly. There are multiple modes for balancing based on business rules. If any weights are applied to the assembly during the balancing process, the machine control sends the information back to the warehouse control system to save with the order. After balancing has occurred, assemblies travel to an audit machine, where the assembly is checked and determined if it passes or fails. Family sets of tire for an order are always kept together. After the tire and wheel have been mounted together as an assembly and have passed the checks, the assembly is examined by a vision system which captures a digital image of the product and compares it with an image in memory. It determines the assembly ID type being seen and passes that value to the warehouse control system. At the tire pressure monitor verification station, an automated antenna system records the serial number of the tire pressure valve and the tire's PSI. And the information is then communicated back to the warehouse control system. The serial number and PSI are tied to the assembly's tracking ID for future reference. The final inspection station process allows operators to replace bad or missing assemblies for an order with safety stock and update PSI information where necessary and do a final quality check. From this station, operators may induct car sets into the ASRS that were manually fixed off the line or that were built as dummy sets for emergency recovery. Family car sets will be processed together at the final inspection station. Usually this means 4 assemblies are processed together. 4 assemblies that use a tire pressure monitor. The warehouse control system receives the actual tire PSI from the monitor station. The WCS compares that value with the allowable minimum and maximum range for the assembly. If acceptable, The final inspection screen shows pass. If not, the screen shows fail, along with the actual value. The operator works to adjust the PSI and enters in a newly achieved value. For assemblies that use valve stems, the operator keys in the actual tire PSI. Any value entered is validated to be in the acceptable range. As the stack is created, the warehouse management system completes the build-to-stock order and uses that information to create a put-away order that is used to stock the ASRS with the set of 4 tires. Only assembled stacks of 4 tires are brought into the ASRS for finished goods stocking. The ASRS module of the warehouse control system puts stacked assemblies into locations in the finished goods side of the ASRS. Locations with stocked inventory levels for the related order are updated in the WMS. BMW sends a daily call-off message, which is a request to pick stocked assemblies for specific orders and ship them to BMW. Pick-to-ship orders are driven by the DCO orders for tire stacks that are already assembled and waiting to be pulled from the ASRS for fulfillment. The order is imported into the warehouse management system, and the location where the entire stack is stored is identified, and an eligible pick is created. An operator uses the assembly pick process in the WMS to release a trailer for picking. Once a trailer is activated, the next orders in sequence are found and released to the ASRS module of the WCS for picking. The Exacta warehouse management system generates rack IDs for the racks to be used for the trailer. The WMS generates all the rack IDs for a trailer as it is opened. Rack IDs are 4 digits plus a left-right indicator. A left-right rack pair will both share the same 4 digits. The racks are placed on either side of the assembly line at BMW, so a car set for a single vehicle is split across a pair of racks. Each rack can hold 24 tires or 12 orders, and a pair of racks holds 12 complete car sets. Each trailer is capable of holding 84 car sets. After the last rack for the trailer is picked, the assembly pick process is used to print final paperwork that is carried with the order to BMW. The RF Ship Verify application prompts operators to scan rack sheets to validate that the racks have been sequenced properly for a trailer. The advanced shipping notice is then sent to BMW upon completion of a trailer load. The system relies upon a robust program written by BMH Controls engineers to operate on a ControlLogix PLC. Communications between the PLC and field devices are carried over a DeviceNet network. Several sophisticated HMI views were developed and deployed at key points in the system. These views provide operators with sophisticated diagnostic tools and comprehensive statistics on essential control points. The system posed several significant challenges to the controls team, the greatest of which may have been the need to maintain the exact position of each wheel and tire in the system without barcodes and barcode scanner technology. The team developed a novel method of tracking wheels and tires through the use of retroreflective photo eyes, already in place to establish a zero-pressure accumulation environment, and track IDs, values in the PLC's memory that are associated with unique wheels and tires, and update as the elements pass from one photo eye to the next. The system has helped CFX achieve many important goals. The plant consistently produces 200 assemblies an hour. This allows CFX to meet BMW's daily production quota over 2 8-hour shifts. The plant can ship a full trailer load of assemblies every 3.5 hours, meeting a key BMW requirement. The facility has never sent a set of assemblies out of sequence, preventing any chargebacks for this type of error. When BMW management from Germany visited the site, they stated that CFX might operate the best tire sequencing facility they've ever seen in their travels. The quality and consistency of the automated processes in place has helped convince BMW to ask CFX to quote the tire and wheel operation for a second vehicle already in production in Greer, the X7 Sport Utility Vehicle. I hope you've enjoyed today's presentation. We look forward to helping you meet your objectives and gain advantage for your business.